everybody. Today we're going to talk about our logarithmic expressions and some different properties that we have that are going to eventually help us solve logarithmic and exponential equations. So to start off with, we're going to talk about the product property. If I have two numbers that are being multiplied together and I'm taking log base b of that product, I can actually split this apart into two separate logs. I can do log base b of m and log base b of n. And what I'm going to do, I'm going to add those two logs together. Okay, so log base b of m plus log base b of n. Now, multiplication is just repeated addition, so that makes sense in how I split it apart. If I'm given this expression to start with, then I can combine the two by multiplying the m and the n together. So I can go both ways, okay? I can expand it, or I can do what we call condensing it. Expanding it means making it longer, and condensing it means putting it all together. Okay, so to condense this into a single log, I see that I have addition, so I'm going to do log base 2, and then I'm going to multiply 7 times 4. I'm going to take the two numbers and multiply them together. So this simplifies to log base 2 of 28, okay? Log base 2 of 28. All right, next, I've got log of 25 and log of 4. If you remember, there's an understood but unwritten 10 right here for this log. So I'm going to take the 25 and the 4, and I'm going to multiply them together. So that would simplify to log 100. Remembering that there's an understood but unwritten 10 right there as the base. Okay, then if I have an algebraic expression, I'm still going to multiply those together. Both of these have log base 4, so I can write them as a single log. Okay, so I'm going to draw parentheses in here. That's going to be 2x times 4x squared. I'm going to do log base 4, and then I am going to simplify what I have. 2 times 4 is 8, and x times x squared is x cubed. So that's condensing them. That's putting it together. Here, for expanding, I want to break it apart. I want to write it in this format. Okay, now sometimes I have these numbers that look like this, okay, and I just need to think of any two numbers that would multiply together to give me 6. Well, right here, I'm going to break this into 2 times 3. So then I'm going to take where I broke it apart with multiplication and break it into two separate logarithms. So log of 2 plus log 3. Right here with this 45, I'm thinking of two numbers that multiply together to give me 45. I could do 9 and 5. I could also do 3 and 15. Really, the combination of those does not matter. So right here, I'm just going to go with the 9 and 5. So I'm going to break this right here into 9 times 5. And then I'm going to separate them into separate logarithms, okay? All right, then right here, this last one has an algebraic expression. I recognize 5x as 5 times x. So right here, I'm just gonna go ahead and I'm gonna break this into log base 2 of 5 plus log base 2 of x. And that is it for the product property, okay? The quotient property, okay? The quotient is like the answer to a division problem. So right here, I see that there is some division happening. What I can do with this, just like multiplication is repeated addition, division is repeated subtraction. So I'm going to take this log base b, and I'm going to separate these two things again into separate logarithms. Now, because the n is in the denominator, it is going to follow the subtraction sign. It's going to come after the subtraction sign. Now, if I'm condensing, and we'll see that in just a moment, anything that follows a positive logarithm goes in the numerator, and anything that follows a minus or a subtraction sign, okay, is going to be put in the denominator. So right here, if I go to condense this into a single logarithm, I see both of them have log base 3, so I know I can put them together. This is going to be log base 3. I'm not going to multiply them because I have subtraction this time, okay? So right here, I'm going to do 24 in the numerator because that is positive log base 3 of 24 minus log base 3 of 8. So because it follows the subtraction sign, the 8 goes in the denominator. Well, I know that 24 simplifies. So log base 3 of 3 is how that simplifies. Okay? All right, next. Right here, I have log base 2 of 15 minus log base 2, 15. Both of them have log base 2. There is subtraction, so I'm going to create a fraction bar. This 15 follows a positive log, so that 15 goes in the numerator. And this 15 follows a negative log, so I'm going to put that 15 in the bottom. Well, what is 15 divided by 15? That would be 1. So log base 2 of 1. All right. Then if I have an algebraic expression, my process does not change. It's going to stay the same. If I have log base 4 for both of them, there's a subtraction sign. I'm going to create a fraction bar. This x to the 9th follows a positive logarithm, so I'm going to put that in the numerator. And this x squared right here follows a negative logarithm, so that's going to go in the denominator. Well, this is not done because I can simplify this also. According to my exponent rules, if I divide two things that have the same base, I will subtract my exponents. So this is going to be log base 4 of x to the 7th power. Okay? All right. Now if I'm going the opposite way, if I'm expanding it, I want to go from this expression to this expression. Now this right here specifically says using the quotient property. So if I'm taking log base 8 of 4, I want to think of two numbers that if I divide them are going to give me 4. Well, the first pair of numbers that pops into my head is 8 divided by 2. 8 divided by 2 is equivalent to 4, so I would not be changing the value, I'm just changing the way it looks. So I have log base 8 and log base 8. And because there is now a fraction bar, there's going to be a subtraction sign between them. The 8 was in the numerator, so it follows the positive log. And the 2 is in the denominator, so it's going to follow the negative log. And that's all I need to do. Okay? For log base 5 of 1/3, there's already a fraction. So I'm going to split this up into log base 5 of 1. And I'm going to do minus log base 5 of 3. The reason the 1 went first was because it's in the numerator. It follows the positive log. The 3 is in the denominator, and it follows the negative log. Okay? All right, then I have this algebraic expression. It's already in fraction form for me. This is going to come first, and then this is going to follow the subtraction sign. So I have log of m minus log of 7. And just as a reminder, there's an understood but unwritten base of 10 right here for each one of these. Okay? All right, and that does it for the quotient property. Now let's look at the power property. The power property is simply referring to when I have an exponent. So right here, if I have log base b of m raised to the n power, this is going to be equivalent to as if I take this exponent and I throw it out front as a coefficient. So that would be n times log base b of m. Okay? So if I have an exponent, I can put it out front, or if I have a number out front, I can move it to become the exponent of whatever this value is, okay? So right here, I have a 5 out front. I am going to condense this into a single logarithm. I'm going to move this 5 and make it the exponent of 2. So log base 4 of 2 to the 5th power. Okay, and if I do 2 to the 5th power in the calculator, that's going to give me 32. So this simplifies to log base 4 of 32. Okay? All right. Number 14, I have a 7 out in front of log base 2 of x. This 7 is the exponent of x. So I'm going to take log base 2 of x, and I'm going to throw that little coefficient of 7 up here as the exponent of x. All right. Number 15, notice I have a fraction out front, okay? Now, just because it's a fraction, it still follows the same rules. It becomes the exponent of my answer, okay? So 8 to the 1/3 power. And if I remember from the very beginning of the semester, I know that when I raise something to the 1/3 power, it's going to be the same thing as taking the cube root of that number, okay? So I can write it like that, or I can consider the fact that there is a number that I can multiply by itself 3 times to give me 8. And that number would be 2. So I could technically simplify this to log of 2. All right. Now if I want to expand, notice this number is already there as the exponent. So I'm going to take this number and just come throw it out front. So that's going to be 7 times log base 2 of 8. And that's it. Okay? Look at number 17, please. Notice my exponent here. My exponent is an algebraic expression. Okay? So very quickly, I'm going to come throw some parentheses around that because I do not want anything crazy to happen to it. It's still going to follow the same process. It's going to be brought to the front and multiplied by this 3 that is already there. So to rewrite this, I have 3 times x minus 1 times log of 4. And I am going to distribute this 3 just to simplify it a little more. So this is 3x minus 3. I'm going to keep my parentheses there, times log of 4. Okay? All right. To start off with for number 18, I need to remember that when I have a square root like this, there is an understood index of 2, and an understood exponent of 1. This 2 comes around to the bottom and becomes the denominator of a fraction. So this can be rewritten as log base 7 of w to the 1/2 power. Now this exponent of 1/2 can get brought out front, and that would be 1/2 times log base 7 of w. Okay? So those are my basic properties. I have the product property, I have the quotient property, and I have the power property. These properties can be used to help us condense our logs or to expand our logs, okay? Now, to start out with, I'm just going to help you with a couple of these, okay? The ones that have just 2, I think you should be okay on based on what we have on the front. But right here, I want you to notice on number 22 that I have 3 different things, okay? So right here, I've got some addition and I have some subtraction. And I have to be able to put all of those things together. I have to be able to condense it into 1. So I have log base 2 for every single one of them. I've got some addition, which means I'm going to multiply numbers. And I have subtraction, which means there's going to be a fraction. So I'm going to go ahead and draw my fraction bar. Now, both the 15 and the 4 both follow a positive logarithm. So the 15 and the 4 are going to go in the numerator. And because there is addition, that means I'm going to multiply those 2 together, okay? And then this 6 right here follows a negative log, so it is going to go in the denominator. So I have log of 2 is 60 over 6. So this finally reduces to log base 2 of 10. Okay? All right, and I also want to look at number 24 with you, okay? Number 24, notice there are some parentheses. An order of operations tells me that I have to do what's inside those parentheses first. So I'm going to ignore this 1/3 for right now, and I'm going to go ahead and I'm going to condense what is inside right here. Because there is addition, I know that I'm going to be multiplying these 2 numbers. Well, 8 times 27 is 216. And that's minus log base 5 of 3. Okay? Now, this 1/3, there's nothing else in my parentheses that can be done. This 1/3 is the exponent of the 216 only because it's attached to those parentheses. So I can say log base 5 of 216 to the 1/3 power minus log base 5 of 3. Well, 216 raised to the 1/3 power gives me 6. So that's going, I'm going to come up here, that's going to be log base 5 of 6 minus log base 5 of 3, okay? Now because of the subtraction, I am going to put these together using division. The 6 is going to go in the top, the 3 is going to go in the bottom, and there's one more step here. 6 divided by 3 is 2, okay? All right, a couple right here. All right, this one says expand each logarithm, okay? These should be okay. Please make sure that you break the x, the y, and the z apart, but notice that this 4 only belongs to the z, okay? So when I get to this part, I'm going to have to do something a little bit extra with that 4 so that it's written without an exponent. Okay, let's look very carefully at number 29, okay? I have q to the 4th, r squared, and then around those, I have a square. Okay, now this square belongs to both the q and the r. I could go ahead and distribute that 2 inside here. When I raise a power to a power, I multiply. So this would be log base 7 of q to the 8th power and r to the 6th power. Okay? The q and the r are being multiplied by each other. So I'm going to break those apart. Log base 7 of q to the 8th with addition. Log base 7 of r to the 6th. When I am expanding, I do not want to leave anything with an exponent. So I'm going to take this 8 and throw it out front, and I'm going to take this 6 and throw it out front here. So this is going to be 8 times log base 7 of q plus 6 times log base 7 of r. Okay? All right. Let's look at number 30. Okay? Again, this 2 belongs to both the y and the z. So I'm going to start out by rewriting this as log base 2 of y squared over z to the 10th. I multiply those powers. So right here, I know that there's going to be subtraction because of the fraction bar. I'm going to start out with log base 2 of y squared. It's up top, so it's following a positive log. And then I'm going to subtract from it log base 2 of z to the 10th power. The last thing I need to do is move these exponents out to the front. So this finally becomes 2 times log base 2 of y minus 10 times log base 2 of z. Okay. All right, so I would like for you to try the remaining problems, okay? Now remember, if I've got a square root, there's an understood but unwritten index of 2 right here. There's an exponent of 1. So when I rewrite this 7x to the 3rd is going to have a power of 1/2. Okay? From there, you can distribute the exponent if you want to, or you could just take that 1/2 and put it out front. The same thing on this one, okay? When I rewrite this, that will be log base 3. I will have m to the 5th n squared. There's a 4 as the index, and there's a 1 understood on the outside. So that becomes to the 1/4 power. Okay. So you're going to work to complete the remaining problems on this side of the page, including number 31 and number 32. I got you started, okay, but I need for you to expand the rest, and then you can check your work with mine. Okay, good luck.